Okay, so we've been working on free fall the last couple days. And in free fall, of course, we have constant acceleration due to gravity. Um, and in our free fall problems, we started with just letting go of the object. So the object was starting at rest. Well, now we want to go to the next level. Now we want to look at objects with constant acceleration. These equations work only when objects have constant acceleration. Okay, and a starting velocity. So notice how our equations have changed a little bit now that we have a starting velocity. Now, if you don't have a starting velocity or you start from rest, that would mean that VI equals 0. And if you look at those equations, if you cross off VI, they become the free fall equations. So look at our first example here, our first equation. If VI is 0, right, our velocity is acceleration times time. So that's the equation that we use for free fall and if you start at rest. Now, if you're in free fall and don't start at rest, then you would use that first equation. Okay, so we have three equations that we're going to use over the next several days. So we're going to spend plenty of time on this. Hopefully, after 3 or 4 days of doing this, it will sink in and you'll be pretty proficient at solving these equations. Another thing I just want to mention is velocity divided by time. This is assuming a constant velocity, kind of like what we just did on the quiz. And notice there's no acceleration. So this equation only works when there's constant velocity or when there is no acceleration. So kind of just wanted to make that distinction there. So these three equations are all about if you have constant acceleration and a starting velocity. All right, so let's go through just what these variables mean. VF is your final velocity. Again, can be positive or negative. VI, starting velocity or initial velocity. A is your acceleration. T is time, of course. And D is distance, sometimes referred to as height. So you might see the Y variable for that. Or sometimes you'll see an X for horizontal distance. Okay, or length or anything that you're trying to solve for. Let's look at a couple of example problems now. Okay, so let's look at this sample problem. A car traveling at 30 meters per second decelerates at 1.5 meters per second squared. How far will it travel before coming to a stop? So I always like to write what's given. So assuming my pen will work here. Oops, I got to hit that button there. VI equals 30 meters per second. So my starting velocity is 30 meters per second. Decelerates at 1.5 meters per second squared. So that will be a negative 1.5 meters per second squared. Notice for acceleration, I'm not using negative 9.8. This is not a free fall problem. This is about a car traveling along the road. Okay. How far will it travel before coming to a stop? So to a stop tells me my final velocity is going to be 0. Okay, and then I'm solving for distance. Okay, so at this point I would look at my three equations, which of course are on the previous slide there. So maybe pause the video and just real quick look back at those. But if you look, you have an equation there. Final velocity squared equals initial velocity squared plus 2 times the acceleration times distance, or x, or whatever variable you want to put in there. So I know VF, I know VI, I know A. I should be able to solve for distance. So here we have 0 squared equals 30 meters per second squared plus 2 times negative 1.5 times distance. Now we want to solve for the distance. Okay. So 30 squared is 900, I believe. Check that on my calculator. Yep. So we have 0 equals 900 plus negative 3d. Bring the 900 over, divide by negative 3, and it will take 300 meters to come to a stop. So write what's given. Look at your equation, see if it can, which one makes the most sense to use. Let's look at another example here. Okay, so let's look at this example. A tennis ball is turned upward with an initial velocity of 12 meters per second. Excuse me, how many seconds to reach its highest point? So write what you know. VI equals 12 meters per second. Now, it looks like that's all I know, but if you're throwing something, as soon as it leaves your hand, now it is in free fall. So for this problem, I would use negative 9.8 meters per second squared for my acceleration. All right, still doesn't look like a lot of information because I want to know what the time is. What is our time for this? Okay, well, you got to remember, as the tennis ball rises and it reaches its highest point, okay, and then it starts to come back down, do you remember what happens to the velocity right here at the highest point? Correct, it will be 0. So while it looks like they don't give us a lot of information, if you draw it out and just think about it, as the tennis ball rises, eventually it will come to its highest point and stop. So I'm going to use VF at 0 in this problem. So I know final velocity, I know initial velocity, I know acceleration. Can I solve for time? Well, look at your equations. And this one should work. We know final velocity, we know initial velocity, and we know acceleration. My T looks a little goofy there. Let's erase that and make a better T. Hopefully. There we go. So now we have negative 12. Bring the 12 over. Negative 9.8T. Okay, so negative 12 divided by 9.8. 1.22 seconds. So again, write what's given. Use that information to decide which equation to use. And then you should be able to plug it in and solve for it. Okay, so now you're going to practice on your own. And if you have any questions, of course, please let me know.